Okay, so now we're talking about 4.2. Now, a lot of 4.2 has to do with these proofs. It has to do with looking at information given to you and then deducing whether or not the given triangles are going to be congruent based upon the information you're given and whether or not you can figure out that last piece. So, starting off, number 9, you're given two pieces of information and you are asked to find the third. Now, remember here, all we've learned so far is side angle side and side side side. So, it's got to be one of those two. So, here we have two triangles. We got EFI and HFG. And we want to look at this and figure out from this information whether or not we can figure out whether or not they're congruent. So we look at this and we see the given IE is congruent to GH and EF is congruent to HF. Okay, so we know that we've got two sides there, which is great because both of the congruences that we've learned so far require two sides. So now we need to figure out whether or not we need that third side, which would be being able to prove that IF is congruent to FG, or we would need to be able to use the side angle side theorem to prove that the included side of both is the same. Now, if we look at this and we see the included angle, not the included side, I'm sorry about that, the included angle, we're talking about angle E and angle H. So we look at that and we go, okay, do we have any information saying that E and H are the same angle? And the answer is no, we don't. So what we do have is that F is the midpoint of GI, so we know midpoint cuts things in half. So based on that information, we should be able to go. We know we're looking for side, side, side here. So what we need to do is put down the information we have and then figure out how we can make sure that we can prove that IF and FG are the same length. This is how we do it. So I want to start off and we say that if, so we put down our givens as always, right? Okay, so now we have IE and GH, EF and HF given, okay? Then we want to put down that second bit of information too. That F is the midpoint of GI, and that is given as well. So then we have to sit there and go, okay, what does midpoint mean? Midpoint means that these two then are going to be completely equal because the midpoint cuts things in half. The definition of midpoint is that it creates two congruent segments. Okay, so the midpoint has two congruent segments. So now we can sit there and we can say that GF is congruent to GI, and that's the definition of a midpoint. So then we look here and we see that we have one side, two sides, three sides, and that's going to give us our side, side, side congruency. So we can just put the two sorry, there's like glitch there, so if it jumped at all, I apologize. So we have the definition of midpoint that gives us our three sides, and so now we can just go ahead and put down that the two triangles are congruent due to a side, side, side congruency, and that's number 9. Okay, so now I want to do one that's going to give us side angle side, and that's going to be number 16. So I'll pick up from right there. Okay, so now here we have, we're looking for BCD, and DAB, our two triangles. So we want to start off by just taking down our givens. So we know that BC, side BC and side DA are going to be the same. It's given. We also know that CBD and ADB are congruent angles. Again, that's a given. So that's going to give us our side and angle. So as we're setting this up, we can see that really what we're looking for here is side, angle, side. Because the only two options we have are either side, angle, side, or side, side, side. Because we're given the angle. Now keep in mind that we're given the angle that it's got to be side. Now keep in mind that the angle needs to be the included angle. So we have our two sides there, and now we want to look at this third side, because that's, if we picked, so that's gray, and let's pick pink. If we picked these two sides right here, sorry about that, that wouldn't matter. CD and AB wouldn't matter, because proving those congruent is kind of irrelevant, because we need the two sides and the included angle. So we need to show that BD is that second side for both. And that's pretty straightforward, because we know that BD is congruent to BD. And that's the reflexive property of congruence. That gives us side, angle, side. And we're done. So again, what you want to do is you want to start off, you want to look at what you have and figure out whether or not you need to shoot for getting that third side, that included angle, or what. So you need to be able to look at the problem and go, okay, this is the information I have, and this is the information I need in order to prove congruence. Okay, so now we're going to look at number 18. Now, 18, 19, 20 require a bit of algebra. That's there in the algebra section. So we have, all we're given are these two triangles with these coordinates. Now we need to remember the distance formula, which I put up there for you. So what I'm going to do is I'm going to walk through, oh dear, okay. So you might have difficulty seeing this, and I apologize. So originally when I did this, I did it all over on the left-hand side, then shrunk them and moved them over there. But apparently that just puts them here in the first place. So we want to take, what we're looking at is AB here, and we want to go AB and DE. Because with this information, we don't really have enough to figure out any angles. So what we want to do is figure out if the three sides are congruent to each other, and if so, that's going to give us side, side, side congruency. Same thing actually for 18, 19, and 20. So here, what we did was we went AB, 5 minus 4 squared plus 5 minus 1 squared gives us 1 squared plus 4 squared. That gives us 1 plus 16, that gives us the square root of 17. So we now know that the distance from A to B is the square root of 17. So now we want to run through the same calculation with DE, and we get the same thing, the square root of 17. Next step, BC and EF. So BC, we're going to start with 2 minus 5 squared plus 2 minus 5 squared. That's going to give us negative 3 squared plus negative 3 squared. We square negative 3, get 9 plus 9. That gives us a square root of 18, or 2 times 9, square root of 2 times square root of 9. That's going to give us 2 square roots of 3. It's actually 3 square roots of 2. I got that backwards. So let's fix that. Three square roots of 2. Okay. So then we have EF, and we get the exact same thing. And again, I got that wrong. So we want to go 3 square roots of 2. So here, check side, check side. So now what we want to do is we want to look at that third side. Okay, and this is originally what they all looked like, and then I shrunk them and moved them over. So here we're looking at AC. We want to look at that last grouping, AC and DF. So we set it up 2 minus 4 squared plus 2 minus 1 squared is the square root of negative 2 squared plus 1 squared. That's going to give us 4 plus 1 equals the square root of 5. So we already have our two sides. So if we can show that DF is the square root of 5 long, we're golden, and we've got congruency. Now keep in mind, on each of these, all three sides need to be congruent. You just can't guess. You actually have to put in the work and run that distance formula twice for each side, 3 sides to each triangle, so you're going to have to run it 6 times total. Which means that by the end of this, you should be fairly proficient at the distance formula again. So here we are, square root of 5 is what we're looking for. Set it up. We want to go 3 minus 1 squared plus negative 4 plus 5. Again, that plus comes from it being a double negative. Negative 4 minus a minus 5. We got that minus right there. And that is going to give us 2 squared plus 1 squared. And that's going to give us that 4 plus 1, or 5. Okay, it's not enough just to do it once or twice or 3 or 4 times. You've got to do it all 6 times. And only then are you going to get the fact that you've got side, side, side. Okay, so some of them might have 2 sides the same, third side isn't, and so that's why you've got to run it all 6 times. Okay, now finally what I want to do is I want to jump to 29, and I wanted to do these. Now each of these later proofs are absolutely on the more difficult side. It requires you to think a little bit more, and it requires you to really rely back on some of the vocab that we learned all the way back in chapter 1 and 2. So here we're given that A and E and B and D bisect each other, and that's the only information we're given. So what we're going to do here is we're going to look at this and go, okay, well, I know that bisecting means cutting in half, okay? And clearly this isn't to scale. But if A and E and B and D bisect each other, then that means that these two are going to be the same and these two are going to be the same. So really what we have to look at is our best bet to show that those two sides are the same. They give us side, side, side. Or do we need to show that both of those angles are the same? So we'll look at this and go, okay, do we know anything that states that A, B, and D are going to be the same length? And the answer is clearly no. Do we have anything that would show that angle C, that BCA or DCE are going to be the same? And they go, yeah, those are vertical angles. So what we need to do is we need to figure that out. We need to go, hey, that's a bow tie angle. Bow tie angles are equal. And then move forward. So we go A and E and BD bisect each other. That's the only information we're given. So we go, okay, well, C is the midpoint of AE and BD. How do we know that? Because that's what bisecting means. Lines which bisect each other have the same midpoint. Do so at the midpoint. Okay. So number 3, now that we have that midpoint down, we can sit there and go, okay, well, if the midpoint's here, and those are the markings I just put up there, if the midpoint's up there, then that means that those two things are equal. Again, this requires you to understand and go back when we talked about bisectors in the first chapter. The definition of bisectors was something that hits at the midpoint and creates two congruent segments. So now we just write down those two congruent segments, AC, EC, BC, DC. And we're going to do that. We're going to call it the definition of midpoint. Okay. So now we sit there and we go DCE is congruent to L or BCF. And the reason we get to say that is that vertical angles are congruent. Okay? So notice in step 3 we were able to peg 2 of the sides. Step 4, stating that vertical angles are congruent, that gives us the angle. We can plug that in, and now we have SAS. So now that we've proven SAS, now we can just go ahead, write down the triangle names ACB, ECD, and do SAS. So let me go back really quickly, make sure you guys have plenty of time to write that down. So a lot of this, guys, is just making sure that you can sit there, look at this, break it down, make sure that you have the information, and write down the information you know, write down the information you need. All of these, if we can prove them congruent, are either going to be SSS, that's side, 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 or SAS, SAS. Side, angle, side. So you need to look and go, okay, well, am I given two sides? If so, do I have the information to find that the third side is congruent, or do I have the information to show that that angle in between the two sides is congruent? So that's one option you have. The other is, if you're given a side and an angle, then you're always going to be looking for that third side, that second side. Because if you're given just one side and one angle, then the only option, the only missing puzzle piece there you have is that second side. Remember that the angle needs to be the included angle. Okay, here it didn't matter. It wouldn't matter whether or not we said angle A and angle E are congruent, because we need that included angle. Other than that, I hope you guys have a great day, and I will see you later. Whether it's Mr. Steiner or Miss Burke showing this, greatly appreciate your help. Thank you very much, and have a wonderful day. Bye, guys.